In this lesson, we are going to work on graphing sine functions and cosine functions. And the sine function will be in the form of y equals a sine b of x, and cosine y equals a cosine bx. So, we've worked on graphing the basic sine and cosine functions. And so today we want to review some of the basic vocabulary, and then we want to be able to do some transformations of those basic functions. So please remember that the domain, or the x values of these sine functions, is all real numbers. We can go infinitely. The range, however, of sine and cosine functions goes from -1 to +1 inclusive. Remember that sine and cosine functions are periodic, which means that they have a repeating pattern that continues infinitely. The cycle of the sine and cosine functions is the shortest repeating pattern, and the period is the length of each cycle. In the sine and cosine functions, using our very basic, the period length is 2 pi if we're measuring in radians. Now, the maximum value of the sine and cosine functions is designated by the capital letter M, and it is showing us what the maximum y value would be. So that would be the maximum of the y value. This also then would be the minimum of the y value, and it is designated by a lowercase m. Next, we want to remember the amplitude, and the amplitude is the measure of change over a single period. And when we're talking about the amplitude, we want to make sure that we remember that the amplitude is the distance from the center, either going up to our highest point or down to our lowest point. And if we are not using our basic functions, we can find the amplitude by taking the maximum value minus the minimum value and multiplying that by 1/2. And in this case, when it's our basic sine and cosine functions, the amplitude will be 1. So what happens when we want to do some transformations? So after working with our basic sine and cosine functions, can we then transform the sine and cosine functions? So using this particular formula, y equals a sine of bx and y equals a cosine of bx. So the amplitude and the period of the graphs are as follows. The amplitude is given to us by the absolute value of a. Now remember that the amplitude, again, always needs to be positive because it is the distance from the center of our function, either up to our highest point or down to our lowest point. Then we want to be able to find the period, and the period, which is our length of our cycle, can be found by taking 2 pi divided by the absolute value of b. Here are a couple of examples where we have found the amplitude and the period using different sine and cosine functions. Now, the other thing that we want to make sure that we remember to find are the 5 key values for our sine or cosine functions. We want to be able to find the maximum values, the minimum values, and also the x-intercepts. And we can do that by using just a simple table. So let's start by practicing on this first example. We want to find the graph of y equals 1/2 cosine of x. Now recall that our form would be y equals a cosine of bx. To find the amplitude, we simply take the absolute value of a. A is the leading the coefficient of our cosine, so the absolute value of 1/2 would be 1/2. So our amplitude is going to be either 1/2 unit up or 1/2 unit down from the center of our function. Next, we want to find the period, or the length of our cycle. Our period is found by taking 2 pi divided by b. Our b value is the coefficient in front of our x, and in this case would be 1. So 2 pi divided by 1 would be 2 pi. Now, the easiest way that I have found to graph this function is to go back to the concept of parent function that we used when we did quadratics. So we're going to start with our very basic values for our cosine function. So here we have our x, and here we have our y value, and y is equal to cosine of x. Now we can call x theta if that makes more sense to you. We want to know what our theta is at this point. Okay? And we're going to use radians instead of degrees, and I think it will make more sense for us. Now if we did use degrees, it would be 0, 90, 180, 270, and back to 360. But going by the unit circle, let's use our radians. So we start with 0 radians, and then at 90 degrees we have pi over 2 radians. And at 180 degrees, that would be pi radians. And at 270 degrees, we have 3 pi over 2 radians. And then once we've made our complete unit circle, we're back to 0, which then, when it's the complete circle, is 2 pi radians. Now, thinking back to what we did in our introduction to graphing sine and cosine functions, we remember that when we're doing cosine, that is the x value in our unit circle. So putting on our points, we would have 0, 1, and then this would be at 0, and then we would be at negative 1 and 0, and then we would be back to positive 1. So if we were to graph, we would take a look at our y-axis. We would have our amplitude. If we were doing our basic function, we'd be at positive 1, and we would be at negative 1. And then our cycle, we would be at 0, and then we'd have pi over 2, and we would have pi, and then we have 3 pi over 2, and then we're at 2 pi to finish. However, there is a transformation that's going to take place in this particular function. First, let's take a look at the period. Our period is not changing. We are not stretching or shrinking our cycle, so that these values are going to stay the same. However, we are going to make our amplitude, instead of being 1 or negative 1, we're going to be at positive 1/2 or at negative 1/2. So all we need to do is to simply multiply all of our y values by 1/2 to find out our new values. So this is going to be at 1/2, at 0, at negative 1/2, at 0, and at positive 1/2. And that, to me, is the easiest way for us to find our new function. So now all we have to do is to graph our points. So for cosine, we start at 0 and 1/2, so we're up here. And then we're down to 0 at pi over 2, and down to negative 1/2 at pi, back up to 0, and then back up to a positive 1/2. And when we graph and drawing in your curve, off just a little bit with our pen, and that will be the curve of our cosine function at this particular values. Now notice when we graph our cosine function and our sine function, they will all have the same exact general shape. But when we transform them, we may either stretch them or shrink them, and we may also be changing the height, where we are stretching or shrinking the height or amplitude of our function. Let's take a look at another example. Alright, so again, remembering that our basic function is y is equal to a sine of bx, where a designates our amplitude. So in this case, our absolute value of a, our amplitude, is going back to our basic function, the absolute value of 1, because that's our leading coefficient, or the coefficient of sine. So our amplitude will be 1. So we can make our amplitude, which is 1 and negative 1. Now we're going to take a look at our period. Our period is going to go, and we are taking 2 pi divided by the absolute value of b, and b happens to be 1/2. So when you take 2 pi divided by 1/2, remember that we would multiply by the reciprocal, which is 2, and so that's going to change our period this time to be 4 pi. It's going to stretch our function and make it longer. So let's take a look again then at the table for our basic sine function. So we have our x, and then we have y equals sine of x. And again, we'll use our radians. So we have 0, and we have pi over 2, and we have pi, and then we have 3 pi over 2, and then we have 2 pi. Okay, now with the sine function, if you remember, we started as at 0, and then we were up to 1, 0, -1, back to 0. But now, we are going to do a transformation. So the amplitude is going to stay the same. The height of our function, the y value, is not going to change. But our x values are going to change because our period is not going to be 2 pi any longer. It's going to be 4 pi. So basically it's going to double, which means we need to multiply each of these by 2. So when we multiply 0 by 2, that's still going to be 0. Pi over 2 times 2 is going to be pi. Pi times 2 will be 2 pi. 3 pi over 2 times 2 will be 3 pi. And then 2 pi times 2 is going to be 4 pi. So basically we have stretched our function. So we simply change our values. And we have 0, and then we have pi. We have our 2 pi, our 3 pi, and our 4 pi. Remember, the basic shape is going to be the same, but we have just stretched it out. So we have our point at 0, 0, and then at pi we're up to 1, back to 0, then we're at -1, and we're back to 0. So now we have our basic shape of our sine function. But this time our period is 4 pi. Let's try another example. In these two examples, and we won't need to graph, we just want to find our amplitude, period, and then the 5 key points of the graph. And the 5 key points of the graph are the minimum values, the maximum values, and the x-intercepts, which we can simply find by creating our table. So the first thing that we want to do is to find the amplitude. And if you remember, the amplitude is the absolute value of a. A is located as the coefficient in front of sine. It is 1, and so the absolute value of 1 is 1. Now we want to find the period. And the period is found by simply taking 2 pi divided by b. And b is found by finding the coefficient of x, which is pi. So in this case, 2 pi divided by pi would be 2. So our period is going to have a length of 2 instead of a length of 2 pi, which means we're simply going to divide each of our values by pi. So we have our x, and our y is equal to sine of x as our basic function. So if you recall, with our basic function, we have 0, we have pi over 2, we have our pi, we have 3 pi over 2, and we have 2 pi. And our values for sine are 0, 1, 0, -1, and back to 0. Now, we aren't going to change our amplitude. We still are going to have a height of 1 or distance of 1, going either direction from our center. But we do need to change our period. Our period is going to be 2. Now, we simply are going to divide each of our values by pi, and that will give us our new points. So 0 divided by 2 is 0, divided by pi. Pi over 2 divided by pi is going to give us 1/2. Pi divided by pi will be 1. 3 pi over 2 divided by pi is 3 over 2. and 2 pi divided by pi is 2. So those will be our new values that we would graph, giving us our minimums, our maximums, and our x-intercepts. So let's take a look at the next example. We have y is equal to 3 cosine of x. Please remember that the amplitude is the absolute value of a, and a is located in front of the cosine as the leading coefficient. So the absolute value of 3 is 3. Next, we want to find the period. And the period is found by taking 2 pi divided by b. b is the number in front of the x, the coefficient of x. So 2 pi divided by 1 would simply be 2 pi. So let's find our other 5 key points that we would graph. In this case, our period is the same as our basic function, so that's not going to change. So we have our 0, pi over 2, pi, 3 pi over 2 in our radians, and 2 pi as we finish our cycle. Then we want to find our new amplitude. So we have y equals cosine of x. And in our basic function, we have 1, 0, -1, 0, and 1. Now, what we need to realize is our amplitude is going to be 3 times as large. So all we have to do is multiply these values by 3. 0 times 3 is 0. Then we have -3. We have 0. And we have +3. So these then become our 5 key points that we would graph to find our cosine function. Let's try one more example, and in this example we are going to find a new amplitude as well as a new period and then graph from there. So the first thing we want to do is to find the amplitude. Remember, the amplitude is the absolute value of a. So reminding you of our function in general form. So our amplitude is the coefficient of sine. Our absolute value of 2 is 2. So our amplitude is now 2. Then we want to find the period of our function. And remember, our period is taking 2 pi divided by b. Now, b is the number in front of the x, our coefficient of x. So we simply remember that there is a 1 in front of the x, even though it's not written. And so therefore that means that our coefficient in front of our x is actually 1/4. So when we simplify, we take 2 pi divided by 1/4, which is multiplying by the reciprocal of 4. So our new period is actually 8 pi. Now we will make our table of our basic sine function. We have 0, we have pi over 2, we have pi, we have 3 pi over 2, and then we have 2 pi. Now, we have changed from our period of being in the basic function of 2 pi to 8 pi, which means we need to multiply each of these by 4 to find those new values. So we have 0, multiplying by 4, we have 2 pi, multiplying by 4, we have 4 pi, multiplying by 4, we have 6 pi, and multiplying by 4, we have 8 pi. Then we have y is equal to sine of x, and in our basic function that's 0, 1, 0, -1, and 0. But our amplitude is going to be twice as big, so we need to multiply each of these by 2 to find our new minimums and maximums. So we will be at a +2 for our maximum and a -2 for our minimum. And then as we graph our cycle, we've divided that into our 4 sections, which will be at 0, and then we're going to be at 2 pi, 4 pi, 6 pi, and 8 pi. So when we graph those, we're starting at 0, 0. Then we're up to 2 and 0, and down to -2 and back to 0. And then we can draw in our sine function. So let's review. When we are finding the amplitude, we need the absolute value of A, and when we are finding our period, we are finding 2 pi divided by B. So let's move on and see if we can model sine and cosine functions. The oscillating motion or repeating patterns in real life, such as sound waves, the motion of a pendulum, seasons of the year, etc., are the ways that we can model sine and cosine functions in real life. Now, the word frequency is the number of cycles per unit of time, and that happens to be the reciprocal of the period. So let's take a look at an example. A tuning fork vibrates with a frequency of 880 hertz, which is cycles per second. You strike the tuning fork with a force that produces a maximum pressure of 4 pascals. Write a sine model that gives the pressure P as a function of T in time, which is seconds, and then we're going to graph the model. So we begin with our basic function, which is going to look like this. P equals A times the sine of B T, where P replaces our y value and T is replacing our x value. So now we're going to fill in the values that we need. So P equals, A is going to stand for our pressure, so that's going to be 4 sine. And then we need to calculate our B, and then we have our T. Now, the way that we calculate the B is that we actually are going to set this equal to our formula that we had before. So, to find our period, we took 2 pi over B. Well, the frequency is actually the reciprocal of this. So we have 880 is equal to the reciprocal of the period. So that's going to be B over 2 pi. And this is the way that we can solve for B. We now can multiply both sides by 2 pi. And when we do that, that's going to give us 1,760 pi is equal to B. So we're going to fit that right in there into our function. 1,760 pi is our B value. Okay? So the first thing we need to do is to find our amplitude. And remember that our amplitude is the absolute value of A, which happens to be 4 in this real life example. Then we need to find our period. And our period, remember, is 2 pi divided by B, which is 1,760 pi. And when we simplify that, we get 1 over 880, which actually is the reciprocal of our frequency. So now we need to find our values to graph. So the first thing, our amplitude, we know that we're going to go from 4, positive 4, to negative 4. And then we need to make our table. So let's get that going. So we have our x and we have our y equals sine of x. So in our basic function, we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. And our values are 0, 1, 0, -1, back to 0. But our amplitude now is going to be 4 times larger. So what we'd like to do then is multiply each of these by 4. So we're going to be at 0, 4, 0, negative 4, and back to 0. Then what we need to do is we need to multiply each of these, or divide each of these, by 1,760 pi. So when we do that, we end up still with 0, and we're going to end up with some strange fractions. This is going to be 1 over 2,200. This is going to be 1 over 1760. This is going to be 1 over 1320. And this is going to be 1 over 880. Now, to graph those, we simply divide our graph into those 4 sections, and then we go ahead and graph. So, this is going to be 1 over 2200, 1 over 1760, 1 over 1320, and 1 over 880. So we begin at 0, 0, and then we're up to 4, down to 0, negative 4, and back to 0. And this would be the graph of this particular tuning fork for the sine function. So, to review, to graph sine and cosine functions, the first thing we want to do is to find the amplitude. We want to find the period, and then we want to find the minimum, maximum, and x-intercepts by our table. And remember, when we do our table, we're going to first do our basic table and then modify it as we need to for our transformation.